Now, the last important thing that we're going to talk about is going to be the feedback schedule and when do we get the feedback and how is that feedback controlled? And so there's a couple different types of schedules of feedback. There's a relative frequency and an absolute frequency. And these are how we report the amount of feedback that people received. And the difference is relative is a percentage of the trials, and then absolute is the actual quantity. So if I have, and so what you see here in the percentages, these are the relative frequencies because it's talking about a percentage. And so if somebody has 10 trials and they only get feedback 5 times, the absolute frequency is 5, the relative frequency is 50%. So that is how we are going to break down how we report the knowledge of results. Remember that when we talk about, we're in the motor learning part of it, and we really need to talk about the learned effect, right? And so from this graph here, there is no idea of what the learned effect is because they don't have any retention test. And this is what that study looks like when we talk about retention, right? So the learned effect. During this process, during the acquisition, both of them seem to be, there's no significant difference in performance. And remember the root mean squared error, so the smaller the better the performance. However, those individuals during acquisition that received feedback 100% of the time, so after every trial, knowledge results, had less learning than those that received it half of the time. And I want you to think for a second why that is going forward, but understand if you consistently get feedback, what is that going to do to your learning? So this idea of fading technique is there's many knowledge results early, and as you remove and reduce throughout practice is going to be a technique that allows you to learn during the later process. Early on, you want to see how you're doing and you can make bigger corrections. But as you become more skilled and practice more, there's a benefit to removing knowledge results and knowledge of performance, because what this allows you to do is utilize your individual self to keep producing the movement. And sometimes you don't want to know always what the knowledge of results are because you don't want to know the outcome. So then another component with this is trials delay versus summary. And if you think back to that previous graph, we had M1, this knowledge results was here, and then you had M2. Well, now what we're going to do is we're going to delay it, or we provide a summary. And a delay is, if you see movement 1 here, there's a period of time, the intertrial transition, and then you have movement 2. Your knowledge of results takes you back to that first movement. So you have a delay in your knowledge results from movement 1 following movement 2. So you have to do some processing to think back to movement 1. And then you do movement 3, and then you have knowledge results of movement 2, so on and so forth. That is trial delay. Trial summary is that you are going to do a number of, this is another form down here of delay, where you have 3 movements, and then knowledge of results takes you back to that very first one. Now, summary is going to be where you actually take a summary of these 3. So this knowledge of results here would be knowledge of results 1 through 3, because you're giving a total summary of all 3 movements combined as opposed to separate. So this idea of summary versus intermediate through both is that period of what is going to look like, and it may be more beneficial for certain tasks for us to give a summary feedback as opposed to individual feedbacks going forward, because there may be a benefit for us to identify and self-analyze ourselves on changing movement patterns. And sometimes you have one movement pattern that is a little abnormal than the rest. But this study is showing that there may be a benefit of this idea of trial summary versus trial delays. But there also is a benefit too if we look over the duration of time where you're utilizing both, where you utilize some sort of trial delay and summary going in the process. What we don't know is what the summary length is for optimization or for the most effective nature. What we do know is it may be different upon different tasks. right? So here you have differences, and so you have a 5 trial average, 5 trial summary, 15 trial average, 15 trial summary, and then feedback after every trial. And so this one, absolute timing error, the every trial feedback does the worst, and then you come down in 10 minutes and you have the 5 trial average. 15 trial may be too much for this individual, but according to tasks, that optimization of summary length is different. Here's another one that shows that the score in this one, the higher it is, right? So it seems to be the 5 trial summary length is the most optimal. You do have the 1, but 10 and 15 trials seem to be detrimental to learning in this particular task.